Hi, this is Molly Fellner, and I have question number 5 on the exam. Basically, in this problem, we're trying to find the reading of the voltmeter when it's attached to this series circuit. To do this, we need to find the current throughout the entire circuit. And to do this, we need the total resistance, and to find the total resistance, we need the equivalent resistance of the parallel section. So the equivalent resistance of the parallel section looks like this. You have 1 over the equivalent resistance equals 1 over 400 ohms plus 1 over 300 ohms, which is the resistance of the voltmeter. When you calculate this out, you'll get 171 ohms of equivalent resistance. Once we know the equivalent resistance of the parallel section, we'll be able to solve for the total resistance, which is just 700 ohms plus the 171 ohms that you already calculated, giving you 871 ohms total resistance throughout the entire circuit. Once we have the total resistance, we can solve for the current through the circuit. We know that the voltage drop across the entire circuit is 60 volts. So 60 volts equals 871 ohms of total resistance times the current, which gives us a current of 0.069 amps. This is where I went wrong when I did the problem. I got about 0.054 because I didn't take the resistance of the voltmeter into account. So I got a much higher voltage than I should have. Once we know the current, we can solve for the voltage drop across the 700 ohm resistor, which is just the current at that point, 0.069, times the resistance at that point, which is 700, which gives us 48 volts. Once we know the voltmeter is reading the voltage drop across the 400 ohm resistor, and since we know the voltage drop across the 700 ohm resistor, we know that the reading of the voltmeter is 60 volts is the total voltage minus the voltage at the 700 ohm resistor, which gives us a reading of 12 volts.